Hello, there we go. All right. So I'm sure this is not the first time that you'll hear someone say this up here today, but I just wanted to personally thank you all for coming out. I love Elixir Conference, and of course we couldn't have Elixir Conference without Elixir developers. So please give everyone here a round of applause. Speaking of Elixir conferences, who here was at the Bellevue, Washington Elixir conference that we had? All right, decent amount of you. Who here attended Tim's talk there? All right, bad news, you might be a little disappointed in this talk. But I hear that while this talk is similar to the one that he gave at Bellevue, he's got some upgrades, which is neat, and I'm looking forward to it because that talk was one of the coolest talks I've ever seen at any Elixir conference ever. So please give a extremely vigorous round of applause for Tim here.
Thank you very much. That was a very kind introduction. I hope I lived up to it. My talk is really for you to inspire you to do some things around you in the world. I want you, first of all, to fall into extreme like with nerves. I'm okay if you don't fall in love with nerves. I would much rather you not fall into it's complicated with nerves, if you know what I mean, from like a Facebook status perspective. Nerves is great. As a member of the Nerves core team, it's my passion. I love the community around Nerves. I love to be involved with it. I like really introducing people to it. I talk about tiny computers all the time. So if you have any questions or anything about that after the talk is over, come and see me or Greg. And I'm sure we'll love to just talk to you for hours about it, and you might not get away. So as we close out Lonestar Elixir, I want us to focus a little bit behind the technology. I don't really want to focus specifically on Nerves. Nerves is great because it kind of takes a back seat. You can write an Elixir application, and Nerves is kind of like magic. It just puts it on the Raspberry Pi for you. So I kind of want all of the technology to take a back seat for just a little bit while I talk to you and share my story. And first, I kind of want you to ask a question to yourself. Why do you write software? Like when we sit down and we sit in front of our editor and we start to type things into the computer, what is it that we're really trying to accomplish? We don't just write software for software's sake, right? Like for instance, if you're doing Nerves work, running the Blinky app is really cool the first time, right? Like you see the blinking light and you're like, yes, I made something happen in the real world. This is amazing. And then you're like, okay, great. I have an idea now. What can I do with it? Like I have this blinking light. Let's move past that. And every time I talk to somebody, they just have this like really great idea, and they want to know if it's possible to do it with Nerves. It's not just the blinking light. They want to change the world around them. So think back to a time when you built something meaningful for somebody, and they saw it for the first time. A user saw your work for the first time. Now, ignore that part because that was probably a train wreck. Think about the second time that you actually showed somebody the work that you did for them after you fixed all the glitches and fixed the user experience and everything like that. How powerful was that for you to have changed somebody's world just a little bit in front of their face? Ultimately, we use languages like Elixir, and we use frameworks and tools and projects like Nerves so that we can change the world around us just a little bit. We want to change the world for someone in some way. In his book, User Story Mapping, Jeff Patton writes, "We measure what people actually do differently to reach their goals as a consequence of what you've built, and most importantly, whether or not you've made their lives better. The world is different for them. Sometimes the way we change the world is small. It's difficult to perceive. Other times, we make a big impact and it's obvious. This is my story about an ambitious project and how I'm changing the world in a small way." So here's how it all started. 13 years ago, my wife Amanda, who's in the audience here, this is her, she found out that she has type 1 diabetes. She had just learned from her doctor. The doctor who made the initial diagnosis had no idea really how to help her. It was kind of a sad state. He didn't really equip her well with the understanding and the knowledge that she needed. And it took us several months to get into an endocrinologist, and then from there it was just a lot more questions than answers. It felt like everywhere we turned there were questions and there were no easy answers. So when that initial diagnosis came in with the instructions to check your blood sugar and don't eat carbs, Amanda had to bootstrap everything she would learn about this disease that would sort of manage her for the rest of her life. Think about that for a minute and put yourself in her shoes. You go into the doctor, you're always thirsty, you're not feeling well, and you walk out of there finding out that you have this life-altering disease that you're going to have to deal with for the rest of your life. So before I get into the technology of managing diabetes and how Elixir nerves fit into that, I kind of want to give you a little bit of background context on the disease itself. So what is diabetes? When you eat, your body breaks down food and converts it into glucose. The glucose enters your bloodstream and causes your blood glucose to raise. Your pancreas senses that glucose and releases a hormone called insulin. Insulin is the key that unlocks your body's ability to convert and store energy. As your body uses insulin, the amount of glucose in your blood drops. In between meals, your blood sugar may begin to go too low. Your pancreas senses that and makes something called glucagon. Your liver and your muscles see the glucagon and release their stored energy to bring your blood glucose levels back up. So what happens when something in this process breaks down? There are two primary types of diabetes, type 1 and type 2. Type 2 is a lot more common. You probably know somebody with type 2. You may not know somebody with type 1. But I'm going to stick with type 1 today because it's the one that impacts me and my wife more personally and the reason that I'm doing the work that I'm doing. Type 1 diabetes is an autoimmune disease in which a person's pancreas stops producing insulin, a hormone that people need to get energy from food. It occurs when the body's immune system attacks and destroys the insulin-producing cells in the pancreas called beta cells. Type 1 has also been referred to as juvenile diabetes in the past, although it can happen to somebody of any age. I have a visual aid. My wife actually found this yesterday. I don't even know where, but this little guy is a beta cell. It's a plush beta cell, like 1 million times bigger than an actual beta cell. And it has a little zipper pocket with insulin in it. So that's really great. So when you have type 1, basically your body's immune system is like, I don't need that insulin. I'm just going to punch you in the face for a while. And this poor little Billy the beta cell probably needs to go back away. But type 1 is pretty brutal in that your body's sort of attacking its own ability to convert energy into something that you can use, and it's just wrecking your life. There's nothing that you can do to prevent type 1. The Juvenile Diabetes Research Foundation, the JDRF, says there's nothing you can do to prevent type 1, and at present, nothing you can do to get rid of it. Type 1 is often misunderstood. Insulin was discovered almost 100 years ago at the beginning of last century, but we still haven't solved diabetes, and why? Because insulin isn't the whole problem. It's not the whole picture. The insulin that diabetics use has gotten so much better. It's very quick. It does nearly as good as the insulin that our own bodies produce, and it's more effective than ever, but it's not the whole picture. It's not all of diabetes. Frederick Banting, the man who discovered insulin, said, "Insulin is not a cure for diabetes, it is a treatment. It enables the diabetic to burn sufficient carbohydrates so that proteins and fats may be added to the diet in sufficient quantities to provide energy for the economic burdens of life." That's a lot of words. Diabetes is not a solved problem. There's often also a stigma attached if you have type 1, that somehow it's your fault for catching a disease. Type 1 is an autoimmune disease, and people like my wife who struggle with it deserve your empathy and your compassion. So what happens to your blood sugar when you have diabetes? Without insulin, our bodies can't convert glucose into energy, so it builds up in the bloodstream. Over the long term, high blood glucose is deadly. It raises your risk for heart disease. It can affect your eyes and cause you to go blind. It hardens your blood vessels. It can damage your nervous system, cause kidney failure, and even affects your teeth and your gums. In extreme conditions of no insulin, your body can't use any of the glucose that's in the bloodstream. And so instead, it takes out fat and muscle instead. And when it converts those things into energy, they emit something called ketones. It's a toxic acid, and it can induce a diabetic coma. So what about low blood glucose? Hypoglycemia. When you have too little glucose, there's not enough energy to keep your body going. It's like a battery, and you're unable to power the most important energy consumers, even your brain. Low blood sugar is dangerous, even for a short period of time. A person loses their ability to think straight, they become dizzy or lightheaded, and they can lose consciousness along with the ability to manage and take care of the problem itself. Your brain can't function, your vital organs can shut down, and the result can be deadly. Diabetes isn't just about food and insulin, though. blood glucose is affected by many things. This is a picture of Scott Hanselman. Actually, it's really funny that his name came up earlier today. It's like everywhere that I go and I talk about this stuff, I hear about Scott because Scott's talking about the same kinds of things. But sleep, stress, anxiety, other hormones, hydration, physical activity, medications, caffeine, and even illness can affect your blood sugar, including public speaking. So those two little like mountains on his blood glucose graph are 2 talks that he gave back to back, and that's the adrenaline jacking his blood sugar up as he talks. It's pretty wild. So what about insulin? When a healthy pancreas produces insulin, it has 2 general modes. It produces a large amount of insulin for the food that we eat. Our bodies are amazing. If you don't have type 1, your pancreas does magic. It just knows how much to deliver for the meal that you just ate. A diabetic person has to do all this math in their head. They have to figure out how much insulin to deliver based on how much food that they have eaten, how many carbs that they've eaten, what their current blood sugar is. It's just crazy. But they do this thing called a bolus. And you can kind of think of it like a bowl of food. A bolus is, the amount of insulin that you take. It's a large amount for the meal. Usually we don't talk about the units of time when you bolus. It's just I took this many units for this food. Over time, in between meals, the pancreas also produces a smaller amount of insulin, and it's called the basal. The basal rate is usually talked about in terms of units per hour because there's a constant sort of background drip of basal going on. Our pancreases just do this for us if we're not type 1, and if we are type 1, then we have to either take special kinds of insulin that are longer lasting, or we'll have an insulin pump that can have a basal rate adjustment for it. So there's the background on diabetes. Let's geek out just a little bit together on the technology that has been created to help diabetic people manage the disease. And I'm going to go to a photo booth, so you're going to see my mug right up here. Sorry about that. Not really sorry. Here's an insulin pump. This device is externally attached to you. Most people have Medtronic, so this is pretty similar to what you probably have seen if you've seen one. This is attached via a tube. I have a wireless one. It's pretty neat. But this tube usually goes into your body and delivers the insulin. It has a very small motor and a computer on it, along with a reservoir of insulin, and basically it can precisely dose just the right amount of insulin for you. There's also something that you've probably seen in I think his name is Wilford Brimley commercials. It's a blood glucose meter. It's a device that measures the amount of glucose in a drop of blood. It's accompanied by this terrible little device that like sticks you and makes you bleed. And if you're diabetic, you get used to it, but if you're me, I've been wearing a CGM all week and doing these calibrations, and it's just terrible. Speaking of that, there's also something called a continuous glucose monitor, and I'm wearing one of them right now. And this is the first one. I've done maybe 6 of these, and I thought I was doing pretty good on the empathy ladder, like with my wife. I was like, yeah, I'm wearing a CGM. I know what you're going through. This is the first one that hurt like you would not believe. And she just kind of rolled her eyes at me when I gasped when it went in. So she's like, yeah, now you kind of start to understand exactly what it's like to be a type 1 diabetic. So along with the technology, the hardware that comes with this, there's also there's concepts. Dealing with type 1 diabetes with all of this equipment is hard. You have to think about how much you're eating. You have to think about these insulin pumps and what you're delivering. You've got just so much stuff on your mind. And somebody in the type 1 community has begun calling this manual diabetes. You just have to do all this stuff to tend to your little farms of equipment and everything like that. So after a while of dealing with type 1 in manual diabetes mode, some smart people started thinking, look, if we can continuously monitor our blood glucose and we can precisely dose insulin based off of an insulin pump, why in the world can't a computer do this for us automatically? Why do we have to continue to do this math in our heads? So the idea of a closed-loop artificial pancreas was born. It's taken the commercial industry a very long time to get there. They actually just released one basically last year. There is a commercial solution for this. But along the way, a group of people decided that they were kind of tired of waiting. There's a hashtag called "We Are Not Waiting" on the internet. If you ever want to see that mentality of the people who have decided that they're going to DIY their own healthcare, "We Are Not Waiting" is the hashtag to go look for. But they decided they were tired of waiting. And so reverse engineers, scientists, hardware and software developers, and of course type 1 people got together and basically built an open source closed loop pancreas. So what are the components of this? In the first phase, there's 3 phases. In the first phase of it, it's called the monitor phase. The computer, whatever it is that's controlling this closed loop, will ask questions. It wants to know, what's your current basal rate right now? How often have you bolused? What's your current blood sugar? It wants to know profile and setting information, what's your current insulin sensitivity, because that can change throughout the day and if you're sick. And it wants to know how much insulin you have left in your reservoir, how your batteries are doing on your insulin pump. There's just a lot of things that are important for a loop. So monitoring is the phase where that all gets collected. Next, we have the prediction. In the predict phase, the computer predicts the blood glucose in the short-term future. So it tries to predict out into the future what your glucose is going to do. It's not perfect. It's going to have mistakes. Just like if you're doing the math in your head, it's going to have some mistakes because it doesn't account for everything yet. The most important and probably most widely available prediction algorithm is called OREF0. Its primary goal really is to do exactly what you would do in your own brain as a type 1 diabetic so that it's not confusing. There's no predictive algorithms. There's no hard math in there. There's no machine learning or anything going on like that, because if it behaves in a way that you don't understand as a type 1, you're less likely to work with it, or you're more likely to just toss it out and give up. In the last phase, based on the prediction, the computer sends a command to alter the basal rate of the pump. If your BG looks like it's going to go up and stay up for a while, it'll actually alter the insulin rate to go higher, that background drip, that basal rate, so that it can push pressure down on your blood glucose to bring it back down into range. Likewise, if you start to go low and it looks like you're going to go low for too long, it'll actually cut off insulin completely. That's really important, especially if you're sleeping and you start to go low. There's a lot of people who are type 1 who have lots of stories about what happens when you go low where you're not awake. But because that loop is really only changing the background basal rate and doesn't deliver large boluses, the algorithm can be out-eaten. You can eat a Snickers bar and basically outrun the algorithm that's going on. You can drink some juice and outrun it. This was an initial key safety feature in just about every one of the open source closed loop ones because, there's software involved here and there's bugs. There's going to be bugs. And so you'd rather not that bug affect your life really negatively rather than giving you the positive benefits of a closed source, of a closed loop. So what are the technologies called that are out there right now that do closed looping? Right now I know of about 3. There's one for iOS devices called Loop. There's one for Android devices called Android APS. And then there's one that runs on a Raspberry Pi or an Intel Edison, and it's called OpenAPS. OpenAPS is by far the most popular one. It's the one that Amanda is actually currently running right now. It's made up of a full Linux operating system like Raspbian or, in her case, JubiLinux. And it has Python packages to manage the pump communications. It has a wireless chip. It has Node for the prediction algorithm. I'll get to that later. And cron jobs and reporting to an internet tool called Night Scout that just about everybody who closed loops, yeah, is that how is that? Everybody who uses any kind of these technologies pushes to Night Scout so everybody else can see what's going on. If any of that didn't make sense or it sounded complicated, just replace it with "it's complicated" in your head, and then we'll get back to that. So in order to start looping, the process can be daunting for anybody, even with a technical background. It took Amanda and me several weeks before we really understood the moving pieces that were involved, installed the right version of Linux, set up all the right cron jobs, and got Night Scout working. While things have come a long way since then in the community and the documentation's gotten a lot better, it's still an exercise in Linux system administration to really get started with any of this technology. So that's where Elixir nerves come in. Even when things are configured correctly, closed looping has technical challenges. Wireless communication is flaky, batteries die, network connections come and go. Just like if you have a phone in your pocket, it has to deal with the same reality, the same real world that you do. Same thing with one of these tiny computers that runs a closed loop. It has to deal with real world conditions. And so as I was learning about OpenAPS with Amanda, I was thinking about it. I was also learning about Elixir. And I thought, what if we didn't have to know all of this stuff in order to start closed looping? What if we just could focus on the algorithm itself and really understand how that's affecting her, and we didn't have to think about cron jobs and everything like that? I've been working in Elixir and learning about it, and I learned how it was fault tolerant. I started reading about like the telephony stuff that was in Elixir's past, and that it could recover from flaky wireless communications and drop network connections. And it did it simply, with simplicity. So at the same time that I was learning about nerves and Elixir, I was also learning about OpenAPS. I started building Elixir applications on nerves. And I loved that it just took care of the details of pushing my application onto a Raspberry Pi and just made it run. So I was starting to put some pieces together, but I wasn't quite there yet. So where closed looping had some technical challenges and weaknesses, I was learning that Elixir and nerves are strong. They complement each other. So I began to learn more. I learned how to pull the continuous glucose monitor pages off of the pump. I learned how to do the wireless communication with the pump. I actually contributed some of that work back to OpenAPS, the Python driver, as well as the Loop app in iOS. So I learned a couple of different programming languages and communities at the same time I was doing this. But I also learned how the history events on the pump could be pulled down and decoded. But it was all still just an experiment to see if Elixir really held up to the promises that it was sold to me as being capable of doing. So what I found was that not only was Elixir capable of this, but it seemed almost like they had made the language for me and my problem and the thing that I was trying to do. It was crazy. I gained momentum. I started to pull more information from the pump, and I was just like running all the commands and doing all these things, and I realized that like I had everything I needed to close the loop in Elixir, and things were really moving. But then I had to make a choice. The core loop part of OpenAPS is called OREF0. It's written in JavaScript. And I thought to myself, what do I do? Do I write this in Elixir? Do I try to port this over and keep up with the community developments that are happening there, and they're happening very quickly? Or do I try to run JavaScript on my Raspberry Pi Elixir app? And I guess that maybe it's a good time for a flashback. So let me stop for a second and talk about the way that I got involved with this closed looping. Amanda actually learned about it while she was researching a 3D printable case for her insulin pump that would also hold her CGM receiver in it. And the internet is just a beautiful rabbit trail. And she's like going through these things, and she found out about this thing called OpenAPS, and she started reading about it and asking questions, and I wanted absolutely nothing to do with it. She said that she wanted to close the loop, and I'm like, no, I can't help you with this. Nope. I didn't want that kind of responsibility. I was worried about what would happen if something went wrong and it was my fault. She asked again, and I told her, look, if you really want to do this, you need to sit down and think about it for like a month. Like, weigh the risks and the rewards. Think about the risks here because they seem like they could be significant. And she came back to me, and with no uncertainty, she said, I want to do this. And I am married to her, so I hope that you understand that I had to help her. Like, I had to go and jump in with both feet and really understand this stuff. So it was like 3 or 4 weeks of just reading documentation and trying to understand how all this stuff worked before I even felt comfortable flashing the SD card that we used on the Raspberry Pi. So still, though, for me personally, taking on the responsibility of writing that prediction and control of the pump is just too much for me to bear. Like, I don't want to be the person that does that work. I'm happy that there are people that do that, but that's not something that I'm interested in. So I decided to find a way to make it work in Elixir that I could actually call out to OREF0 and include Node into that nerves application. So I learned how to do a custom nerve system, which was exciting. Greg's smiling at me right now. Nerves custom systems at the time, at least, were pretty difficult. But I figured out how to put Node on that Elixir application. Yeah, so I had JavaScript everywhere. It was great. I'm going to take an aside really quick. The nerves community is so great because you can literally go into the nerve Slack channel and say, look, I have a crazy idea, and I think that I want to build a closed-loop insulin delivery system with nerves. And people are like, yeah, I mean, that seems good. Let's do that. Like, where else can you go to have that kind of an experience? This is so good. I love the nerves community, and that's why I'm so proud to be part of the nerves core team. Anyway, back to the present. What's the state of the project that I'm doing? If you were at ElixirConf, you saw the first time that the closed loop actually ran for me. It evaluated my blood sugar and my pump settings, predicted my blood sugar, and changed the flow of insulin, which was actually just air through a tube, through the pump. And then it pushed it up to Night Scout. We all saw the result that were there, and that was really exciting. And just like during ElixirConf, I'm wearing a continuous glucose monitor right now. And I kind of want to show you, I hope it worked. This is my blood sugar while I'm giving this talk. I'm really sorry if you're type 1, because this graph is just brutal. These things are flat every time, and it's so uninteresting, but I can't do anything about that, and I really don't want to be type 1. So you can see at the top, though, there's the basal adjustment to me, and also just the straight line of my continuous glucose. I've eaten food, and it goes up to maybe 140, and then literally 5 minutes later, it's back down to 100. And that's the way that a functioning pancreas looks. So sorry that it's uninteresting and boring, but that's the way that it is. So since September, the application has been modified a couple of different ways. There are some people working on open source hardware to fit on the Raspberry Pi called phats that will communicate with the pump. So those two sets of chips that are being used, I wanted to be able to support those as soon as they came out. I thought they would be out by now. They're actually not. But I did build some prototypes. I actually soldered them myself. You can come up and look at the terrible work that I do on that. But it's really fun because now I can actually just plug in either of those prototypes, and it'll boot up, auto-detect the card, the chip that's being used, and just work. I thought that would be difficult, and like most things with Elixir, it just kind of happened. And I would look back at it like, how did I write all this code that works? And it didn't make any sense to me. But that seems to be a recurring theme for me with Elixir. I've also gotten some great contributions to the project. Luke Imhoff is here, and Luke actually helped me with type specs in the pump communication library. Did a great job documenting some things about diabetes in the code that I don't really understand still, and that's just fantastic, and I really appreciate your contribution there. There's also a guy in Spain named David Gill who added a better implementation of the JSON posting to Night Scout. So it's really cool to see people contribute back to the project who potentially could benefit from it or are benefiting other people. My focus has kind of turned to the Phoenix side of things. I have basically a configuration page, or I had a configuration page, and that was it. And that was, you'll see that here in a minute. But I really wanted to be able to replace the need to have Night Scout if you're offline looping. So not pushing up to the cloud, but being able to see what's going on with the loop locally. And I'm going to click this tab over here, and I really hope that it works out well. Oh, cool, it did. Yay, okay. So these green are sensor glucose values. And you can actually see the predicted ones, I hope you can see, are the ones that are not filled in. This is it basically predicting out for the next, it looks like 30 to 60 minutes for me of what my blood glucose is going to be. Again, sorry, it's kind of boring, but hey, it's there. So I kind of want to demo. How many of you have seen a Nerves application from the mixed firmware point on? Okay, it's a little less than half, I think. I kind of wanted to demo that experience. As a Nerves core team member, it's really exciting for me to get to share this kind of stuff with you. So I'd like to kind of show you what it looks like when you're building a Nerves application and walk you through the experience of somebody who would potentially be setting up this loop for the first time. Okay, so like all good Nerves apps, this is a Poncho app. And if you have any questions about what a Poncho app is, go talk to Greg after this is over. It's basically an umbrella app minus some of the ceremony that's in an umbrella app. But all of the applications are basically flat next to each other. There's a UI app, which is a Phoenix application. It gets embedded into the Nerves app when it gets built and run. And then there's also the FW, which is the firmware application, and that's just all Nerves. There's also a few other apps in here, but the really important one is this APS one. That's the automatic pancreas system. And that's where the loop, it lives and where it shells out to the node application and things like that. When I'm building the application, I go into the firmware folder, and I run, you specify a mixed target. In this case, I have a custom system, and you run mixed firmware on it. So I'm going to do that, and while I do that and wait for it to finish, I have some other things I wanted to talk about. So we'll just watch that go. So I kind of just hand-wavy talked about how Elixir was ready for this application before I was. I kind of want to talk about that just a little bit more. A lot of the communication with the pump happens over packet radio, sub-gigahertz packet radio, and there's just all these like frames and things that go back and forth. And once you're done with pulling like a page of data, you have 1,024 bytes of stuff, and it's all encoded. So you have to like pull that apart and actually figure out what it means. At some point, I got so good at reading these CGM pages, you can kind of see one over here, I think. Yeah, I got so good at reading some of these CGM pages, I could tell whether it was glucose or like a special sensor event just based on looking at these things. I think that's when I realized that I went a little too deep on this. But like you have to basically flip the binary around backwards, traverse it in reverse, and then pull apart potentially different sized events from this history table. And Elixir was just like, yeah, sure, I do binary pattern matching in the function head, sure, just like write the code. And I was like, okay, I need to structure this right. Oh wait, no, I'm done. Like I just wrote it in the function head. Now what do I do inside the function? Because I got to deal with this data that I've already structured up. And so it was really cool to have those kinds of experiences like left and right when I'm writing this Elixir code. So it looks like this worked. The next step when you're doing a firmware is to burn it. And it will auto-detect where your SD card is. So it has a 16 gig one in here. I'm going to tell it, yeah. Sign in blood. And it is done? No. Of course, it had to do that. That wrote an entire operating system along with a Nerves application. It still feels like magic when that happens. Okay, I'm going to do a Frank move. Frank is on the Nerves core team also. Pull the SD card while it's still powered up. I don't know why he does that, but it's so much fun anyway. All right, so this is basically the vanilla version of the loop application. And I'm plugging it back in. Oh, here's some of my soldering handiwork. I know you probably can't see it, but that's for the best. All right, looks like it's coming up. So while it's coming back up, you're going to see a lot of really cool crashy stuff happen here because it's not configured at all. And that's another core component of Elixir, right, is let it crash. Let it crash, importantly, the code, not your blood sugar, right? That's the important part about let it crash. Like earlier today, I had it running over at the table, and I went out for coffee with somebody, and I had the insulin pump with me. And so, of course, it was out of range, and it was just crashing, right? And I came back, and as soon as I sat back down at the table, it was like, okay, I can run a loop again, and it did it, and it picked up right where it left off, and it's like, this is all just magic, and it's so amazing. So it's trying to run a loop, but it's not configured. Let's go configure it. It's hard to type with one hand. I shouldn't do that. Don't look at all my super secret information. Really needed the pump serial. All right, so I'm going to feed it some Wi-Fi information so it can push up to Night Scout. And then tell it where Night Scout is. And I'm not smart enough yet to make it just do this without rebooting, so it's going to reboot. And while it's doing that, some of the other fun things that I found along the way with this adventure was I was using the UART, the Nerves UART library to do serial communication. And while I was doing that, I learned a lot about low-level hardware kind of communication, and I wanted to be able to capture what was going on between me and that insulin pump, but not have to have the insulin pump there, so I could investigate what had happened later. And so I actually wrote essentially VCR for Nerves UART, which I've since learned was a terrible idea, but it was a lot of fun to do it. And so I could play back these communications with the pump as though the pump was there even when it wasn't. So interacting with hardware and faking it out was a lot of fun in this project. All right, it looks like it is started back up and it's starting to loop. So I guess maybe we'll just watch this happen here, and then I can kind of close up with the feelings that I have and where I feel like this project is headed. And then I have a couple of other things. So hopefully it's back up and running now. Cool. Okay, so it's an empty graph because it hasn't run the loop successfully yet. I'll just let that be for a minute, and we'll come back to it. So I haven't yet connected all of that technical stuff that I just said was in the background that I just showed you in the foreground with the start of the talk. How is this going to change somebody's world? More specifically with my work, how is this going to change the world for a type 1 diabetic? Imagine if instead of having to obtain a degree to understand all of this stuff, you could just download the project, figure out how to burn it to an SD card, and then configure it via a web page. That is a much different experience than what Amanda and I had the first time that we did this. What if you could focus on your disease management and understanding how the closed loop works rather than like Linux and cron jobs and Git source control and everything? The benefits of closed looping are personal and dramatic for us. Amanda's A1C, which is like a 3-month indicator of your blood sugar, went from 7.0 to 5.8. A reference range for a non-diabetic person can go up to 5.6. So she was basically almost within range of somebody who doesn't have diabetes. That's pretty cool. Her roller coasters of highs and lows smoothed out, and her time in range has improved. It was a regular event for us to have alarms in the middle of the night. I'd have to hear the alarm and she'd sleep through it, so I'd wake up and I'd just lovingly give her a smack to say, deal with your high or your low here. And now we both just sleep through the night because we don't have those as often. It's a rare event. We both sleep better. So the work that I'm doing has helped me to empathize better with my wife, and she has used it to better understand how to manage diabetes. One note that might seem a little bit out of place in a talk like this where I'm talking about how impactful this work is, that I kind of hope it goes away. Since Angel Jose spoke yesterday and gave a disclaimer, I feel like I'm kind of obligated to do the same thing. His actually mentioned the FDA. I'm not going to. But if you're type 1, I am not trying to convince you to do this. This is like a deeply personal kind of a decision, and you should make that yourself. I'm certainly here if you have questions, but I'm not telling you that this is a thing that I think you should do. Keith Cottrell also in his ElixirConf USA said he wished that we would start as a community, as an Elixir community, and like putting disclaimers up at the beginning of our talk about financial disclosures. So I'll do that too. I have no financial interest in this. I don't want to make any money off of it. That's just not what this particular thing is about to me. But what I do want you to take away from my talk is a point of inspiration. I want you to have a heightened desire to empathize with people around you and use your ability to write software to change their world a little bit and to improve it. So that's my story. And here's what's cool. There's a lot of other people doing really amazing stuff. And it's not just me working on this project. It's a ton of people doing great stuff to improve the world around them with Elixir. I did put out a question on Twitter about a month ago, maybe a little bit less, of who's using Elixir to change the world. And I got a few responses that made me really happy, and I really enjoyed those conversations with those people to find out what they were doing. There's somebody creating a German sign language video tool in Elixir, and it's a Bitboxer on Twitter. I'm not sure how to pronounce his name, and I really don't want to mess it up. So, but it's basically a dictionary. It's whenever there's new words or combination of words that come out, you can upload a video of yourself signing it so that other people can benefit from that and use that, and you can learn sign language that way, or you can learn new words in sign language that way. Jared Smith at Inside Track is using Elixir for coaching, student coaching, so connecting coaches with people going into higher education to improve their success rates. That's really cool. I mean, that's really amazing. Joshua Richardson and Catalina are here. Where are you? Yeah. So they're working at NAV to help small businesses succeed with credit, understanding what improves your credit score, and also understanding lending services and things like that that are available to you. It's just really neat to hear the stories of people who are impacting the world around them with Elixir positively. And I've heard from other people at the talks this weekend and just in the community in general, on the Slack channels and everything, people are doing such amazing work. So keep it up. Let's keep this wonderful Elixir community going, and let's push each other a little bit further to use our resources to meaningfully change the world around us. I will mention here at the end, I work at Gaslight, and the reason that I put this slide here, well, it's cute, but the reason I put this slide here at this part of the talk is because I feel like Gaslight really does that. We're out there to improve the craft of software delivery. to bring meaning to the people around us and to share what we learn with other people around us. If you feel like that aligns with you and you're interested in a job, or you think that we might have some work that we could do for you, just come see me afterward. So here's my information. I'll put it up again at the end. I did want to say, before I finish, there is one more thing, to steal Steve Jobs a little bit. NERVS 1.0 release candidate just came out yesterday, if you saw it in the Slack channel. So yes, it's almost there, and it looks like we might hit our fall of 2017 date. So I'll go back here really quick, and there's my blood glucose running again. I assume that there will be some questions. I think I finished pretty early. Yeah, so if anybody has any questions for me, I'll take those now.
All right. Question time. Let's see some hands.
I'm sure this is a scary prospect, but is there any long-term plans for yourself or anyone in the community on not having to shell out to Node? Like, is it a, and this isn't a loaded question or pressure, I'm just curious, is it a very difficult algorithm? The way you described it sounded simple, quote unquote, but is it more of a personal liability, where you're just not comfortable yet? Or if it just works, it's not broken, don't fix it type mentality?
Yeah, so when I started and I tried to read through it the first time, it was about 400 lines. I think it has ballooned to a little over 1,000. I don't have any short, medium, or long-term plan personally to do that. I did have somebody come up to me at ElixirConf. I won't say him by name because I can't remember his last name anyway. But he said he was interested in porting it over sort of as an exercise to see what it would be like. I am more comfortable shelling out the Node than I am in rewriting it. I'll say it that way. It does concern me a little bit just in terms of having JavaScript be at the core of the loop, but the people who are writing that, it's a good division of labor. They understand the domain really well. It's Dana Lewis and Scott Libran. They're really good at what they're doing, and they're getting good engagement from their community. I feel like I would be pulling away from them if I did it anyway, so yeah.
You mentioned, you kind of hacked together sort of a XVCR for testing.
Yeah.
Kind of curious, when you were testing this stuff out, I imagine there was a great deal of trial and error. What did you end up with as sort of like a test harness for this so that you could, iterate pretty quick without having to necessarily plug it into yourself or your wife and hope for the best?
That's a really good question. I don't feel like I ended up on a good solution yet. I did get rid of the VCR, but something that's kind of interesting that is helping me to iterate more quickly on this is that with NERVS you can actually run in host mode or in target mode, or you can crash wildly in front of people. You can actually run the application on the host as though it were on the client, and because it's shelling out the node and doing other things, I can do all that on the host as well. So as long as I configure it correctly, it's not going to find a chip to use, but I can still turn around and visit the algorithm locally and see what it thinks is going to happen with the glucose and everything. So. Yeah, as long as I can fake out the data with some realistic looking data, then it works out pretty well. I'm not sure if that answered your question very well, but yeah, I basically moved the abstraction from VCR at the very low level up to where I would consider testing my own code and not testing somebody else's. I'm just moving it up to the layer where I'm actually physically faking out a physical pump with a fake. It's called pump fake. Yeah.
Any more questions?
So if you do have questions and you don't feel like asking them publicly, that's totally cool. Amanda's usually the person that everybody swarms at the end of this talk, so you can feel free to swarm her. I'm also available, and I'll answer any questions that you have for me as well.
Just as cool as the last time you gave it because of or I should say even cooler because of the Phoenix integration. That's awesome. Now please give them a round of applause.